All right, so okay, so this is 5.5.6. Okay, let's figure out the solutions of problems here. Okay, sigma x, y, mu x, mu y, and then correlation rule is given. We gotta find out covariance, and then mean and standard deviation of marginal probability distribution of x. Okay, and then yeah, so find the probability x is less than 1/16. Okay, and then mu x bar. I mean, this is the mean of conditional distribution, probability distribution, right? And then, yeah, okay, so stop share. Okay, okay, okay. Um, First one, what is one? No, C, correlation. So give me a second. Okay, so now right here. So keep in mind this, the bivariate normal distribution, distribution PDF is fx, y, right? Okay, x comma y, that is going to be 1 over, okay, 2 pi sigma x, sigma y, okay, square root 1 minus rho square, okay, times e to d. Exp means e to d, okay, and then x minus mu x square over sigma x square, I mean variance, minus 2 rho, and then x minus mu x, then y minus mu y, rho over sigma x, sigma y, okay, plus y minus mu y square over sigma y square, okay. Yeah, I forgot the constant term times negative 1 over 2 times 1 minus rho square, okay. So I know it's complicated to memorize it, but yeah, so please be familiar with this, okay. And then when you solve the last problems, remember that in that online homework section, in the last problems, you may see different form of that one, okay. Yeah, actually, but they are equal, okay. So keep in mind that. All right, so now what's the question, by the way? So let's see, question is this. Yeah, covariance. Okay, so the problem give you, this is 5.5.6. So sigma x is a 0.5, and then let me skip writing unit, millimeter, okay. Sigma y is just 2, and then mu x is 120, and then mu y is 100, and then rho is 0.6, okay, 0.6, okay. So let me see now what. So covariance A, problem A, find the covariance, okay, COVXY, right? So COVXY is E of XY minus mu X mu Y, remember that? Or you can say this is expected value of really of X minus mu X times Y minus mu Y, okay? All right. But let's see. I don't think because what the problem doesn't give us any information to find out this one, E of xy, okay? So I don't think we can use that formula, okay? And what about this? I don't think we can figure out this one. We can figure out covariance xy using that formula. So let me use other formula, okay? So what formula, I mean, what formula involve the covariance xy? Correlation, right? You see, correlation is actually C of covariance of x comma y over sigma x sigma y, isn't it? Or can say sigma xy. This is the symbol of covariance xy, right? Sigma x, sigma y. Okay. So rho is given, which is 0.6, right? That is equal to sigma xy over sigma x and sigma y is given, which is 2 and 5. So I mean 5 and 2. So 5 times 2. So that's going to be implies sigma xy is what? 6, right? Okay, 6. Right. So please yeah, memorize all these formulas. Okay, please memorize all these formulas. Okay. So now next one, problem B. Question B. So mean and standard deviation of marginal probability distribution. So by very normal distribution, marginal probability distribution of x and y are also normal distributions with the mean of the bivariate normal distribution. So here mean and standard deviation must be equal to mu. The mean must be equal to mu x. Standard deviation must be sigma x. Okay, so keep in mind this. So remember that here. A second. Give me a second. Yeah, let me share. Which one? So I think let me see right here. So remember that here. Look at this. If x and y have bivariate normal distribution with a joint probability density, okay, the marginal probability distribution of x, y are normal with mu x, mu y, and sigma x, sigma y respectively, right? So that's what I'm talking about. So keep in mind this. And then also this one, the conditional distribution of bivariate normal random variable mu y bar x is equal to this, and then variance is this. We're gonna use this one too. Okay. So now the what's the question? Yeah. So here, mean the fx of x. This is a marginal probability distribution, right? Is normal distribution. With a mean mu x is 120, and then sigma x is 5. Okay, and the fy of y is same thing. Okay, I mean is a normal distribution. Okay, with the mu y is 100. The sigma y is 2. Okay, where those numbers come from? These numbers from the problem. Okay, problems give us that information. And I see. Find the probability that x is less than 116. Okay, all right. So now this is equal to. Oh yeah. So since what? That means we find out marginal probability distribution where x is less than 116, right? But marginal probability distribution is normal distribution because a bivariate, I mean, that joint probability distribution is a bivariate normal distribution, okay? So now that we find out, we can, we can find out this one using the normal distribution curve. So we find out G-score, remember that, G-score? So what is G-score? G-score is the, x minus mu x divided by sigma x. Remember that? So here x is 116, okay, minus mu x is 120 over sigma x is 5. Okay, all right. So let's see. That's gonna be what? Negative 4 over 5. Okay, so here, see. But anyway, so this one is less than, I mean, not here. So what I do is less than 116. I mean, not 116. We find out the G-score of 116, sorry. That's going to be negative 4 over 5, which is negative 0.8, right? So this is going to be negative 0.8. Okay, negative 0.8. So using the, the normal distribution, standard normal distribution table, or you just use calculator, either one just fine. Okay. So using calculator, you don't have to find out G score of this. You don't have to transform this onto this. So you just use, remember that? Go to the distribution right there. Okay. Distribution, and then normal, we use normal CDF, right? So lower is negative 9999. Negative 99999. Upper is what? 116. And then mu 120. Sigma 5. The calculate. So we got 0.211. Okay, well, but the rounding, the 100 digit, so we got 0.212, right? This is a 0.212. Okay, so now next, that was C, and then D. Mean and variance of conditional probability distribution of X, given that Y equals 102. Okay, so find out mean and variance, okay, of conditional probability distribution of X, okay, given that Y is 102. Okay, so now we find out mean of conditional distribution, mean X for Y is equal to 102. So now I told you this is now here we have to use the formula of the what, the this one I show you. Remember here, you see conditional distribution of bivariate normal random variable. Okay, right. So the mean and variance of conditional probability distribution is this. I mean, assuming that X and Y have bivariate normal distribution. Okay, it's going to be mu Y. Okay. This is what? Actually, this is a conditional what? Conditional probability distribution of Y given that X. But here, this in the problem D, conditional probability distribution of X given that Y. So we have to switch X and Y, right? So this is mu X, okay, plus correlation, and then mu X, sigma X over sigma Y, and then Y minus mu X. So here we plug in 102. Okay, so 102 is a Y value, right? Okay, so now sigma X is 120, and then in the problem says that correlation is what, 0.6, right? Times sigma X 5, sigma Y 2, and then 102 minus sigma X is 120. Okay. Oh, sorry. So right here. Okay. So I just switch X and Y from the formula. Okay. So I plug in 102 into lowercase y, and then I plug in sigma X, sigma Y, and then row the numbers giving problems here in the formula. So we got this. Okay. So next question. Here, and then similarly, we can find out sigma square and variance x bar y is equal to 102. You can calculate this one by looking at the formula. Okay, so let me skip it. So, and then yeah, so also E. Give me a second. Give me a second. So now see, what about E? E. So find the conditional probability that x is less than 116, given that y is 102. Okay. See, this is a conditional probability, right? Then x and y have bivariate normal distribution. So I told you conditional probability distribution with mean. is also conditional probability distribution is also normal distribution. Okay, that is normal distribution. A normal distribution. Okay, if x and y have a bivariate normal distribution, okay, the normal distribution with mu x bar y is equal to, we just got this, right? The problem E, question D, right? Okay, and then sigma x bar y variance, we just got this one in questions D, okay? So we got these two numbers from previous question D, okay? So now using this one, we can change this one to like this. This is equal to probability that we change this one x and then x to the z score, okay? To z less than, what is this? This is gonna be what? We apply the formula of z score for the number 116. So 116 minus mu x bar y over sigma x bar y. Okay, so that is equal to probability that z less than 116 minus, yeah, so yeah, you figure yeah, you just figure, you have to figure out these two values from this equation. It's D. Okay, so now then you plug in them and then find, looking at the standard normal distribution, the table, you can find this, or just use calculator I showed you, right? So using the distribution, go to the distribution, okay, you can figure out the probability. So this is the 5.5.6, and the next one, see. Okay, so reserved problem, chapter 5, section 4, problem 2. Okay, so let's take a look at it. So suppose that a random variable x and y, can you see that? That's better, right? So suppose that the random variable x, y, and z have the joint probability density function. See that? The PDF is defined by C, a constant. So this is a constant function. Joint PDF is a constant function. But look at the domain over the cylinder. X squared plus y squared is less than 1, and then z is between 0 and 3. And we can, so the question problem asks us to find out the covariance and correlation x, z, okay? All right, let's figure out that. So, oh, okay. First one, this is, yeah, yeah. Okay, these are the problems, 5.4.2, okay? Here, one thing that you should keep in mind is, if joint PDF is a constant, okay, it will happen. So when you figure out the, when you identify one of the property of the probability distribution function, that is integral of joint PDF, the d, let me say just dx, dy, dz is equal to 1, okay, right? So that must be 1, right? Because the problem says that this is the joint, probability distribution function, right? So PDF, that is equal to 1. But the problem says that this is C, constant. So now then, since this is a constant, we can bring out the triple integral, right? Okay. So let's see here, domain, D, let me say put D, okay, that means domain. Then 1 times D, 1 and then dx, dy, dz equals 1. But what is this? If you take a calculus 3, you know this, right? That's what? That one, when you triple integral of integral 1 is equal to what? The volume of the domain. Okay, volume. What's the domain? Your x-axis, y-axis, and your z-axis. Okay. The volume is what? Cylinder. The problem says a cylinder right here. So I know, like the cylinder right there, right? So height is the bottom says what's height? Height is 3, right? And then the radius of the top and bottom is 1. So here's a 1, here's a 1. Okay. So that triple integral of integral 1 must be equal to the volume of this. We know the volume of the cylinder, pi r square, which is the area of the bottom, or we can say area top times height, right? So now here the volume is going to be excuse me, pi times r square h, right? So that is what? R is 1, h is 3, so we got 3 pi, right? Okay. So c times pi, so from back to that formula, we can say c times 3 pi is equal to 1. So what? C is equal to 1 over 3 pi, right? Okay. So we figured out C. Okay. So now we find out the covariance and correlation. Okay. So now let's see covariance. Okay. So first question is find the covariance X Z, or you can say what, sigma XZ. Okay. Okay. I mean, what is sigma, to find the sigma XZ? We're gonna apply the formula of the covariance, right? It's gonna be expected value of xz, right, minus mu x mu z, right? Okay. So then covariance exz. What is exz then? X. Oop, xz. That's gonna be, since the what we deal with the continuous random variable, so that's gonna be here triple integral, and the x times z times join the PDF, which is c, right? I know we just figure out the c, which is a 1 over 3 pi, right? So let me plug in 1 over 3 pi later. So this is dx and dy and dz, but we need to figure out the limits of integrations, right? What's this? Okay, so yeah. mm, now, so yeah, please review how to determine the limits of integration in triple integral. Okay, so in let's just look at the let me review the calculus 3. Okay, textbook. Keep in mind this. Okay, so we don't have time to cover that part. Okay, so now what I'm going to do. So here I told you, but the rule is this: the most outer the limit of integral must be a number. Okay, all right, and then so it's here. So I'm gonna take integral with respect y first, and then x next, and then z at last. Okay, so the limits of integration of z gonna be 0 to 3, right? 0 to 3. Okay. Next, limits of integration for x is the what negative 1 and 1, right? Does it make sense? Because look at this. Is it okay? Is it? Okay. So now then, here limits of integration for x is a negative. Yeah. Let's say be 1 to negative. Here's a negative 1 right here. The limits of integration for z is a 0 to 3. See? But now, what? While x is moving from negative 1 to 1, the limits of integrations will change, right? For example, when x is maybe negative 0.5, the limits of integration is what? Is not from negative 1 to 1, but, you know, it should be what? That, you know, the range, I mean, interval from here to here, I mean, interval for that one is what? Depends on the value of x. So to figure out this one and this, we have to figure out relationship between x and y. So equation at the bottom is what? X squared plus y squared equals 1. because there's a circle. We know that. Now, let me solve that equation for y, okay? And then y is equal to plus minus square root 1 minus x squared. So now you see that the bottom going to be negative square root of 1 minus x squared, and the top one going to be square root 1 minus x squared. So we expressed the upper limit and lower limit in terms of x. Okay, so the most inner integral must be integral with respect to y, and the lower limit must be square root 1 minus x squared, and the top one going to be square root 1 minus x squared. Okay, so it makes sense. Why? Because here in the integral, this is dy, right? Dy. When you take that integral, we're going to get function of x. Now look at the middle integral. This is an integral with respect to x. Yeah, it makes sense. That's what it makes sense, right? Okay. Now after that, we're gonna get what? We're gonna add number, and then integral with respect z. We can do that, right? Okay. So what if you change dy dx? Then you're gonna get big trouble. Why? Because if you just integral order integral as dx, dy, dz, what happen? Then the when you evaluate the outmost integral, you have the what? You're gonna deal with the function of x, but the outmost integral is a integral with respect to z. Doesn't make sense, right? Okay, so now then see, this is the c times x times z, right? Okay, so now this is equal to c bring out, and then z also bring out. Look at this. This is the integral with respect to y. So we can consider z as constant, right? So we bring out 0 to 3, and here z. Okay, and then negative 1 to 1. Okay, the negative square root 1 minus x squared, square root 1 minus x squared, and then x dy dx dz. Also, we can bring out x right here because this is integral with respect to y, so we can consider x as a constant. So I bring out x out of the integral with respect to y. Now here, so we take integral with respect to y first. So this is going to be what? That's going to be y, and then minus square root 1 minus x squared, square root 1 minus x squared, right? So that's going to be, excuse me. So now this is equal to what? Square root 1 minus x squared minus square root 1 minus x squared, which is 2 times square root 1 minus x squared, right? So now this is equal to c times 0 to 3, and then z times the negative 1 to 1, and then 2x square root 1 minus x squared, and then dx dz. Okay. So, what is this? Oops, sorry. Sorry. Yeah, something messed up. Yep. So now then what? Here from there, let's see, this one, okay, right here, let's see, okay, bz, then what? This is equal to c times 0 to 3, and then z times, what is this? Okay, we have to apply what? U substitution, right? I think we can apply U substitution. So from there, let's say u is equal to 1 minus x squared, then du is negative 2x dx. So dx is negative 1 over 2x du. Okay, and then we have to change the limits of integration, right? So when x is negative 1, we're going to get 0. When x is 1, we're going to get 0. Oh, that's good news, right? Because the limits of integration is 0, 0, right? Is it? And then square root of 1 minus x squared going to be square root of u, right? Okay. And then when we replace dx with this one, then we're gonna get negative 2x gonna be gone. We got negative sign and then du, right? And then dz. So since, by the way, since the lower limit, upper limit 0, 0, so that integral is just gonna be 0, right? Okay. Then integral of z times 0 d 0, right? So this is 0. Okay. All right. So xz is 0. Exz gonna be 0. So this is 0. Okay. See. So now what about mu x, mu y? So mu x is what? F. Oh, sorry, not F. Mu x. This is ex, right? That's gonna be 0 to 3 and negative 1 to 1, and then negative square root 1 minus x squared, and then square root 1 minus x squared, and then x times, isn't it? Okay. F x y z, and then x comma y comma z, and then this is dy, and then dx dz, right? Okay, but that's the c, right? Okay, so that is equal to c times 0 to 3, and then negative 1 to 1, and the x times, okay, so now negative square root 1 minus x squared, the square root 1 minus x squared, and then dy dx dz. But we already calculated this, right? What was this? That turns out to be 0, right? Remember that? You compare this. We calculate this bar, so it turns out that what? Remember that? 0, right? Is it? So here, this one 0. So c times integral of 0 with respect to z is what? 0. Similarly, mu y also 0. Okay. So now covariance must be 0. Okay. Covariance, this is 0, this is 0, 0. So 0 minus 0 times is 0. Okay. So similarly, we can find out the covariance of yz and the covariance x and y. Okay. So similarly, so that's the let me see. Second here. Okay, let's see. Yeah, that's the I just solved the two problems. Okay, so I hope that one helped you a lot. All right, so we back to, give me a second. What is this? Give me a second. Oh, too many. Okay. Okay, sorry. Now, next one, let's see. Oh, yeah, this one. Oh, yeah, so now we move to, oh, not this one. Let's see, my lecture note. Okay, so Bivariate normal distribution, we did that. And then, yeah, I didn't prove this, right? So, but please look at the this one, okay? And then give me a second. One. Yeah, let me go over this. Okay, so here. Yeah, I'm sorry, I don't have enough time to go over this. So, let me see. We covered this. We covered that, and then yeah. So now here. So correlation of Bivariate normal random variables. If x and y have Bivariate normal distribution with a joint PDF, the correlation between x and y is rho. Give me a second. So let me prove this. Okay. So here. Give me a second. So as you can see that I'm going to use that corollary. Okay. So E of xy equals sigma x sigma y times rho plus mu x mu y. I mean, before doing that, okay. So you may wonder that what is this? X and y is rho. What is rho? Rho is the correlation of x and y, right? Okay. So now X and it means even if even though X and Y have bipolar normal distribution, the correlation of X and Y is still raw. That's the meaning of this. Okay, but now then we're gonna use this. So we use that corollary. Yeah, let me prove this one next time. Okay, so just take a look at it. E of xy is equal to sigma x times sigma y times rho plus mu x times mu y. Keep on this, and then the second corollary is this. Covariance of x comma y is exy minus exey. Yeah, actually we proved that, right? But we can prove this one using corollary first corollary. But anyway, now then we apply the two corollaries in there. So let me see. So right here. So the first one, corollary one, was what? The covariance. Give me a second. Okay. Corollary one was, well, this. Oh, not this one. I'm sorry. EXY. That is equal to sigma x, sigma y, rho, plus mu x, mu y. The corollary two was covariance. Yeah, this is covariance x comma y is equal to exy minus mu x, mu y. Now then, rho, this is a covariance x comma y over sigma x, sigma y, isn't it? Then this is equal to exy minus mu x, mu y over sigma x, sigma y, right? Okay. So now then this is equal to exy is what? We can plug in this one right here. So we got sigma x, sigma y, rho, and then plus mu x, mu y minus mu x, mu y is what? 0. So we got this one over sigma x, sigma y. That is equal to 0. Equals what? Rho. Okay. So the proof is done, right? So the for even though the even though x and y have bipolar normal distribution, the correlation must be rho. Okay. So let me that's for today. Okay. Let me stop here. So give me a second. Let's see.